Hello, and welcome to Passing Parameters in Python. So in our last video, we talked about functions in Python, basically little modular sets of code that are developed for one purpose and provides modularity and reuse possibilities to our programs. Now what we need to understand, if we're going to have these functions, usually what we're doing is passing data to these functions to actually do something with it. And with that, we need to talk about what a parameter is and what an argument is, and so on. We need to understand then, how can we pass data? How can we receive data? By value, by reference, and we're going to learn something what's called call by object, okay? And so we'll talk about the differences there based upon what you already know and how it actually works in Python. We'll talk about the different types of ways to really pass arguments to a function. There's some flexibility there, kind of easy, but adds a lot of flexibility to your programs. And finally, we'll end this video talking about scope of variables. We haven't really talked about that yet in regards to this language, but there are different types of scope of variables based upon where you actually declare the variable, something you already know. I'll talk about that a little bit here. All right, so let's get started. So as a review, a function or procedure usually needs some information to do its work. The interface between a function call and a function consists of special variables that are called parameters. Again, the parameters are what is the term that deals with what you receive. The syntax for how parameters are declared and the semantics for how the arguments are passed to the parameters of the function or procedure are depending on the programming language. Kind of an interesting statement, but one you just need to understand. Every language is a little bit different. So as you get to know programming, understanding programming, especially going through some of your beginning programming languages, the goal here is to understand that most programming languages do the exact same thing. They all have the ability to write functions, okay? They all have the ability to pass data. They all have the ability to do the structures of programming, arrays, doing databases, and so on. Your job is then, once you have the concepts down of what a program can consist of and what you need to be able to write your program, you need to understand, be able to ask the questions, well, how do you do it in this language? Once you start doing that more and more and more, learning new languages is very, very simple. But based upon this last piece right here, your job is to understand the syntax based upon what each language is asking you to do. So if I was to learn Java and I wanted to be able to define a function, probably what I do is just Google, how do you write a function in Java? How do you pass data in Java? How do you receive data in Java? That's what you do when you have these functions or procedures, correct? Well, how do you do it? And basically, you can find that answer pretty darn quickly. Programming is programming, people. It's pretty much the same thing all the way through once you learn one language. Very often the terms parameters and arguments are used synonymously, but there's a clear difference. Parameters are inside functions or procedures, while arguments are used in the procedure calls. The values passed to a, meaning basically that's the values passed to a function at runtime. So what we pass is called an argument, what we receive and what we use is called a parameter within the function. Does that make sense? Sometimes people call them the same things. Just as long as you understand the difference, there is a distinct difference, and it's nice to understand this terminology. Unlike other languages, passing data in Python, passing data in Python is quite simple. Okay, so in this case here, it should be DEF. I apologize, that should be a lowercase d. Printname, str message. But pretty much what you're doing is passing this argument to this parameter. And that's how you do it. It's just one-to-one in this case, okay? Another example could be this one, where we're going to find the average, where we have an int number 1, int number 2, int number 3. In this case, what we're going to be doing is call find average, as you can see. It's going to return the average over here, okay, once it's called, and I'm passing 10, 20, and 30. Note, these need to be in order. 10 is going to represent number 1, 20 is going to represent number 2, 30 will represent number 3. It will do all its work, and it's going to return the average. Just that simple, all right? These can actually be variables, of course. I could have int value 1, int value 2, int value 3, and pass them accordingly. But once again, they must be in order. So if I have these things out of order, it will not recognize what it's trying to do, or it could throw you an error based upon if you're intermixing data types in some cases. But as long as everything's in order, that's how you pass that's how you pass arguments to a function. Pretty simple, right? But the key is, based upon what we know, how is a parameter received? When we pass a variable, it can be passed either by value or by reference. You should know that already, right? By value passes only the value. It can't be changed. If the value is changed in the procedure or function, it will not reflect that change when returned. So if I actually receive it by value, correct, and I make a change in the procedure or function, that change won't be reflected once it's returned from the function, okay? By reference, on the other hand, passes the location of the value in RAM. Recall this? This allows the procedure or function to change the value and reflect that change upon return. So if you recall from some of your first programming classes, we did talk about by ref and by value, and we used by ref to return values back that needed to be changed. All right, that's what these two are. In Python, it's a little different. Most languages kind of deal with that. Even C deals with it. C deals with by reference very strangely. It's called a pointer. So if anybody takes the C class here, you'll learn all about pointers. The one that does the best job with by reference is truly the visual type languages. However, Python does not distinguish between by value and by reference. It passes arguments by object, or in other words, by object reference. Let's talk about what that means. That means that it deals with, what this means is that it deals with how it handles the data passed to its functions based on the type of data it is. This is actually kind of unique. If you pass variables with data types that are integers, floats, or strings to a function, the passing acts like a call by value. So they are considered immutable arguments, which means arguments that can't be changed. That's what immutable means, can't be changed. Mutable means it can be changed. So mutable can be changed, immutable can't be changed, just in case you need a vocabulary lesson today. Sorry about that. So integers, floats, or strings in Python are considered immutable arguments. They cannot be changed. So if you pass an argument to a function and change it in the function, it will not be that change will not be reflected upon return. Does that make sense? So in Python, simple variables like you see right here, meaning individual variables, integers, floats, and so on, cannot be passed by reference. It can only be passed by value. Now, how do we get around that? Well, there's a lot of ways of getting around it. Once again, you return a value to it, make it a global variable, and so on. But you cannot change one of these types of data types within Python. However, you pass a list or an array. Once again, many of you may not know what an array is at this point in time. Some of you do. But based upon what you've taken and so on, if you don't know what an array is, but that's fine at this point in time. We're not going to dive into it too much. We will a little bit later on in this course. But an array or a list is what it's called in Python, is considered a mutable object. With that, there are various ways to change that list, and the changes are reflected upon the return of the function. Since many of you are not familiar with arrays, like I said, we're not going to really talk about that right now. There's no need to talk about it. We'll kind of deal with that a little bit later on in the course. All right, so right now, for this most simplistic sake, all arguments are passed by value in Python. All right? I think that's probably the easiest way. All right? Function arguments. You can call a function by using the following types of formal arguments. Let's don't make this any harder than it is. Required arguments, keyword arguments, default arguments, and variable length arguments. Let's talk about each of these as we kind of go through it. Required arguments is probably what you know the most or understand the most. Required arguments are arguments passed to a function in the correct positional order. The number of arguments in the function calls should match exactly with the function definition. That's what you've been doing all along. That's called a required function, required arguments, right? So 20, 30, to number 1, number 2, add me, and so on, okay? Probably you're going to write your functions and so on, especially in this course, most of the time like this, 98% of the time like this. But there's some flexibility to this. Excuse me. There's something called keyword arguments. Okay, keyword arguments are related to the function calls. When you use keyword arguments in a function call, the caller identifies the arguments by the parameter name. This allows you to skip arguments or place them out of order using the Python interpreter. Out of order because the Python interpreter is able to use the keywords provided to match the values with the parameters. Let's look what I mean by this. In this case, when I call add me, I have the keyword int number 2, int number 1. It will pass these things accordingly because it matches the actual name of the parameter within the function. So the argument matches the name. I put these out of order for sake of example, but this would work fine. It doesn't have to be the exact order. These are called keyword arguments. Okay? What's kind of nice about them, it allows you some flexibility, especially when we get into some of the default things. We'll talk about that here in a second. So default arguments is an argument that assumes a default value if a value is not provided in the function call for that argument. So in this case here, the following example gives an idea of a default argument. It prints the default age. It does not do that. So in this case here, what it does is add me, int number 2 equals 30, okay? And so in this case, I'm just passing int number 2, but I gave a default to int number 1 equals to 20. So I'm passing this one. Because I did not pass number 1, it's going to add 20 to 30, and the total for this particular case would be 50. Now you might be asking, okay, it's defaulted to 20, what's that mean? Well, if I pass int number 1 and make it equal to 50, it will take on the 50, whatever I pass it. The default is only if nothing is passed to it. And so if I wanted to write a function where maybe some things are, optional to be passed to it, you may want to give that option, whatever those variables are, those parameters are, a default. And this way everything will work within your particular function. Does that make sense? Okay, default arguments. Okay, and so once again, just make sure you understand that. Okay. Variable length arguments. These are actually pretty cool. And once again, something I'm not going to get into right away because it kind of deals with arrays, but you may need to process a function for more arguments than you specified while defining the function. These arguments are called variable length arguments and are not named in the function definition, unlike required and default arguments. This one, when you can go out and look at an example if you like on your own. I'm not going to dive too much into it right now. We will maybe a little bit later on in the course, but for the most part, what this allows you to do is kind of create an array within the function itself to receive as many, pieces of data that you want to send to it. So it can be completely flexible. And so at one point in time, if you want to add, find the average, let's say, of 3 numbers like we did before, okay? We passed 3 numbers. But maybe I want to find the average of 10 numbers, 20 numbers. Matter of fact, we want to write a function that can take the average of any amount of numbers that you send to it. We can create a function that has variable length arguments up to as high as you want to take it. Does that make sense? So kind of a neat thing, okay? Really dynamic, really flexible. And then what you would do is literally loop through that array that you guys are going to learn about eventually and process it, okay? So there you go. All right, scope of variables. The last thing that we should be noted is how scope of variables is defined in Python. Okay, scope, as we know, is the lifetime of a variable. Scope is also of a variable also refers to places that you can see or access a variable. So when we talked about scope a lot in your previous programming languages, we talked about its lifetime. When does it go out of memory? So we can actually use our resources as efficient as possible. When we're looking at Python, the efficiency of resources is not so much the need for scope. It really comes down to where can we access variables based upon where they're defined. That's really the second one there. Does that make sense? In Python, there are 2 types that we will talk about now. These are different from any visual type languages that you may have seen, VB and so on. We have local and we have global. Okay, we don't have class level at this point in time. We have local and global. So for the most part, does local something that you already are somewhat familiar with? Let's talk about these. First, let's talk about global. If you declare your variable outside of a function, it is global. So if you declare a variable anywhere in your code and it's not within a function itself, it is considered global. What does that mean? That means any function can access its contents and change its value. Not only can it be any function, but any piece of code within the program itself can access its contents and change its value. That could be quite beneficial, don't you think? Okay. If I declare a global variable and I have a function, I can access it. That's what a global variable is for. Local, if you declare your variables inside of a function, it is local, meaning it can only be accessed and changed within the function itself. However, you can pass that variable to other functions for the means we discussed already in this video. All right, so if I have a local variable and I want to, and again, the life of that local variable, let's think about the life of this real fast. The life of a local variable lasts throughout the function. Once the function is completed, it will remove itself from RAM. Global variables will hang out there for the life of the program, all the way through the program, okay? So if you want to pass a local variable, you can actually do this. So if a function calls a function, obviously you will pass those local variables and go from there. All right, global or kind of outside of it, and everybody can access it. Just a nice thing to know when it comes to Python and writing your programs. All right, so a little different than other languages, but I don't think all that hard. It takes away this whole aspect of, I guess, passing by ref and passing by value. Everything's by value in Python. You'll note that in other languages. The same thing holds true in C. Everything in C is passed by value. You can pass it by reference, but to do so, you have to go through sort of a few hoops to do so. If you already know what C is, you probably already know the answer. You got to actually create a pointer to point to it. So it's a little bit different, but Python doesn't deal with pointers, all right? However, like I said before, once you get into arrays and so on, you can actually pass it, and it does treat itself a little bit more like by reference. All right? So there you go. You should know everything you need to know now about functions to be able to move on and see if you can try some of this stuff. All right?